Okay. Okay. So let's go back to our. So this was just to give you a kind of a introduction. So how I mean, what all things I am working upon right now. So let's just go to our recap. So what we did in, let me just go back. I think we did file path exceptions. Oops. Okay. File path. Okay. So just a quick revision. Okay. So we wanted to work with the path. So what was the basic understanding of a path is the complete path where you are storing your data. So this is the path. So I'm in C drive, then I'm in users, then I'm in this folder, then I'm in this folder, then I'm in this folder. So this is my path. This is my actual path. So I want this to be programmatically represented. So how programmatically I can get this path? Through this. I can import a module which is called as os. Then I can create a variable which is called, I mean, you can create any variable. So I'm just using cwd, then os that get cwd. So get cwd is an inbuilt function in this os module. So what this will do, this will try to return the current path of this particular file. So if I run this, right, so what I'm getting it here is the path of this uh, particular file. Which file? This file path.ipynb. Okay, so I'm trying to get this. Similarly, we can do multiple things. If I want to create a new directory, I can use os.mkdir. Okay, mkdir means, by the way, make directory. So I can use mkdir in Linux as well. So here I'm just using os module, and then I'm putting a dot, and then using this mkdir function, so which will help me in creating a directory. So whatever directory I want to create, I can give the name, and this will result in creating the directory. That's it. Very simple. And if I want to list the files in the directory, so I can use items.os.listdir. So this will help in listing the directories. Okay, so I'm using dot means current directory. I'm pointing to my current, wherever this file is, that directory. If I run this, if you see, it is returning me a list. See, list str. It will return a string, a list which has strings as an input. So this complete list return. All these are present in my current directory. Then I can join the path. I can use a function which is called as a join. If I want to join this and this, whenever I'm creating a path, right? So I can use join function. So you might say, okay, we have concatenation also, right? I can use a plus also, but concatenation will not add this slash. Okay, it will directly join folder and this string and this string. It will not add this. So join is used whenever you are dealing with paths. Okay, so we just have to use os, then dot path and dot join, and then we will give our input variable. So what is the directory name here and the file name here? Okay, and then yeah, so what I'm trying to do here is I'm getting the current working directory, and with that, so this was my output up to this. Yeah, up to this was my output from this function itself. Then what I'm trying to do, I'm adding this folder name and this file name. I'm joining this. If you see, I'm joining this and then this. So we try to understood similar operations with the os module. Okay, yeah, and this was the very good example. So in this, what we did, right, we validated whether this path is valid or not. So what we did was we use this function, we use os module, then path, and then is file as a function, and to validate whether this is a valid path or not. If it's a valid, if it's a valid path, then print sorry, if it's a valid file on this path, then print it's a file. If it's a directory, then print it's a directory. If it's neither the directory, neither the file, then print this else statement. Okay, path example is a file. So we already have a file, then this point gets executed. Then absolute path. So absolute path means complete path. There is something called as a relative path also. So relative path means, so for this particular yeah, this particular file, the relative path is directly going to the only directly going to this this file. Directly going means Yeah, directly, because I can directly access this, right? So for me, the relative path is the file name itself, but the absolute path is complete path from starting to end, from C, users, couple documents, MLOps, this is a complete path. Okay. Okay, so this completes our file path, and then we went through exception handling. So what were exceptions? So exceptions were used to gracefully stop the program or terminate the program. The program can terminate by itself also. I mean, if there are an error, program will terminate abruptly. But there are certain situations we do not want to terminate the program abruptly. We want to slow it down. Okay, we want to terminate the program in our way. Okay, so there could be some exceptions. These are common ones: zero division errors, which we can you can say track or monitor, and whenever this error comes, right, we can print something or we can handle this exception. Then file not found, value error, type error. So if I do like this, a is equal to b, so a is a variable but b is not defined, right? So this is resulting in what? This is resulting in name error. Okay, Python is telling you this is a name error. So the type of error is, or the type of exception is, name error. So name error, name b is not defined. So when we try to handle exceptions, right, so we follow a kind of a syntax. So this syntax says you have to try. What we have to try? We have to try this. If there is an exception, okay, it could be anything. If there is an exception, please print this message. Do not print this message. Okay, print this message. So we are handling this in a certain way, right, our own way. So if I run this, even though b is still not defined, I have not defined b, the error will be the same, but we handle it through this particular format. So try and accept handle it. So accept collected it, and then we are printing this message. The value of the variable is not defined. So we can print any meaningful message, whichever we want it to be printed. Then again, now we are directly pointing towards a name error. Pointing towards name error means we are explicitly saying only to this accept block, only collect or handle name error. And once you handle this name error, you have to store it in this variable, and then we will print this variable. Okay. So name b is not defined. Where this x got the value, this x got the value from here. See, name b is not defined. So name b is not defined. So we collected it. But if there is, so let's say if there is another error here, so this exception will not be able to handle, because we explicitly say you have to handle only the name errors. You see, it's a zero division error. This is not handled by this. Why this is not handled by this? Because we are not handling this error, particular error. Okay. So in the next, so here what we are trying to do is we are only handling zero division error. We are not handling any other error. Okay, so we printed the error message, and then we printed a meaningful message like please enter the denominator greater than zero. Okay, and it got printed. So this resulted into zero division error, and then we printed it. Okay. Then right now what I'm trying to do is I'm trying to incorporate both of them. Okay, zero division error and accept exception. So if I comment the below part, I'm only catching the zero division error, not the name error or any. So if I write like this, right, I'm catching all the errors which could incorporate whenever I'm running this error. So if I comment this, right, I'm capturing only zero division error. So I'm only capturing. So if you see, zero division error is not highlighted here, only the name error is highlighted here. But if I add this line, all the errors, all the other errors, if it's a zero division error, it will be captured here. If it is any other error, it will be captured here. So ex name b is not defined. So it's a name error. So then this line got printed, and main exception got caught here, and we printed this message here. Okay. And if I do like this, you see, ex z division by error. Oh, z this line got printed. Please enter the denominator greater than zero. This line got printed. So based on your input, you will have the errors. Uh, this is also a similar example. Just we have added the else part here. Okay. So we have one more finally. Yeah, let's do this one. So what is, okay, it's trying, let's say I give 0 here. Okay, so it's taking input from the user. So enter a number. I have to enter a number. So if I enter 0, right, what is telling? You can't divide by 0. So it is captured here. If I enter a 0, it is captured here, because 10 by 0, it's a 0 division error. Okay, so and let's say if I type hello here, let's say what will happen now. What it is telling, this is not a valid number. Which block got executed? Because it's a value error. I'm not giving a proper value. And if you see, finally will get execute every time, whether you have an error or not, it will get execute. Okay, and if it's not an exception, if it's not a 0, if it's not this, then else will print. If it's not an exception, okay, let's try to do, if it's 2 here, yeah, so the result, this line got printed, else part, because when we say 10 divided by 2, so we got a 5, right? So it's not a value error, it's not a 0 division, it's not any other exception, so this part got printed, and finally always has to be printed. Okay.
Hey everyone, hope you enjoyed our session at LWP Labs. For more videos like this, you can subscribe to our channel and contact the number for live classes. The future is now with AI.